name's Elena and I'm doing the chapter 15 video homework. So first of all, a strong acid will have a conjugate of a very weak base. A strong base will have a conjugate of a very weak acid. A weak base will make a weak base will make a weak acid, and a weak acid will make a weak base. Now that we know that, we can look at our molecule, see how it dissolves, and take a look at its conjugate. So carbonic acid is a weak acid, which means that carbonate is a weak base. Barium or barium hydroxide is a strong base, making its conjugate a very weak acid. So now we know that this is a very weak acid and this is a weak base. We can tell that the weak base is stronger than the very weak acid. So the weak base will dissociate better than this one, meaning that when this is in an acidic solution, it will dissolve more than a very weak acid will dissolve in a basic solution. So the barium carbonate will dissolve best in an acidic solution. Lead bromine, or dibromine, will break down into lead and bromine. We look at the conjugates and we see that hydrobromic acid, I think I said that correct, will be a strong acid, making bromine a very weak base. Lead hydroxide will be a weak base, and so its conjugate will be a weak acid. Now, a weak acid is stronger than a very weak base. So the weak acid will dissolve better than this will, and this will dissolve best in a basic solution. I don't know why that's happening. Okay, and then we have barium sulfate, and the conjugate of the sulfate is sulfuric acid, and that is a strong acid. The conjugate of barium is barium hydroxide, and it is a strong base, meaning that this will be a weak acid, and this will be a very weak base. This will be a very weak acid, this will be a very weak base, and since they're very weak, both of them are very weak and will hardly dissociate, the conditions will not matter whether it's basic or acidic because they have a hard time dissociating in either.